Alright, so now we're going to talk about events involving not and or. Basically two different subtopics of probability, so we'll take them one at a time. Earlier we talked about how the probability of an event is always between 0 and 1, and so the probability of an event happening and the probability of an event not happening is always equal to 1. So if we look at that equation and we solve it for P of E or P of not E, then we get the following known as the complement rules of probability. Okay. So what I'm going to do is I'm going to take the equation that we have here and I'm going to solve it for P of not E. It's up to you if you want to do this or not. Eventually you'll have to know both of the formulas that I'm going to show you, but they're both derived from this. So if you remember this and you can do the following, then you only need to know this formula. So I take this P of E plus P of not E equals 1, and I'm going to solve it for P of not E. P of E, I'm going to subtract P of E. So we get, of course, that's 0 plus P of not E equals 1 minus P of E. So, of course, 0 plus P of not E is just P of not E equals 1 minus P of E. Okay, which is what I have here. P of not E is 1 minus P of E, and then by a similar argument, P of E is equal to 1 minus P of not E. So I could have done the same thing up here, but instead of solving for P of not E, I could have solved for P of E. Okay, so these are both true. And in some examples, you'll need this one. In some examples, you'll need this one. Again, you can always just start with this equation and then solve either of those. So let's look at an example of probability of something not happening. We're looking for the probability we are not dealt a club. So we have to remember our deck of cards. In a deck of cards, we have spades, hearts, diamonds, and clubs. Okay? So the probability that we're not dealt a club. So I guess I have to remember we have a deck of 52 cards, so the number of things in our standard deck is 52. In the other section, we discussed that a deck of cards has 4 suits, which I just showed you, these 4 suits. If there are 52 cards in a deck and 1/4 of that deck is clubs, then 52 divided by 4 is 13. So there are 13 clubs. Okay, so the number of clubs is 13. In this problem, it wants us to find the probability that you are not dealt a club. So remember, the probability of something not happening is 1 minus the probability of it happening. Okay, so I'm using the second one. Probability of, oops, I should write that as a club. Probability of a not club is 1 minus the probability of a club. So the probability of a club is 13 over 52. If you want to go ahead and reduce that now, you can, or you can wait until the very end to reduce it. All right, so I'm going to wait till the very end. I'll just go ahead and plug this in. 1 minus the probability of the club is 13 over 52. And I just wanted to show you, I can type this in directly. Carefully. 1 minus 13 divided by 52. Trying to find the light here. It's a little better. All right, got to be careful with your parentheses. All right, you get this decimal, 0.75. We should know what that is. Second PRB, 3/4. So, the probability of not choosing a club is 3/4. Well, you probably could have figured that out without using the formula, but I like to use the formula here because in some examples, it is easier to use the formula. Okay, so what do I mean by, well, you don't actually have to use the formula. Okay, so this is using the formula in 11 point, or in this section. I'll be careful not to use section numbers in this formula, or this section. All right, that's what we just did here. If I want to use the formula or methods from a previous section, I could do that. So let's think about what we did in the last one. If I want to know the probability of something not being a club, we already know we're going to divide by 52. How many of these cards in this deck are not clubs? I mean, I could count them, right? I could count everything that's not a club, but you probably realize we don't have to go through all of that, right? We know that there are 13 clubs, so the number of cards that aren't clubs is 52 minus 13. Which is 39. Okay, so the number of cards that are not clubs is 39 over 52. If I type that in the calculator, oh, that looks familiar. So in some of these examples, if you would rather work it using a different method, in most of the cases you can. It doesn't work for every single question, and in some questions it might be more complicated to do it this way. But if it's a simple question with rolling a dice or a deck of cards, it might be just as easy to use this one or this one. All right, so let's look at probabilities involving OR. We have two situations here. Either the scenarios are mutually exclusive or they are not mutually exclusive. Okay? Mutually exclusive means they have no overlap. It is impossible for two things to occur at the same time. Okay? Some people don't like Venn diagrams. I don't like to get too much into it. Hopefully you understand the basics. So the idea, if two things are mutually exclusive, if I do have a Venn diagram, call this A and this B, they have no overlap. They are mutually exclusive. They cannot occur at the same time. Things that are not mutually exclusive do have overlap. So here's A, here's B. There is some overlap if they are not mutually exclusive. So even though we don't know a lot about Venn diagrams, I think that's understandable. But that helps us with understanding our formulas. If they are mutually exclusive, then the probabilities of A or B happening is a probability of A plus probability of B. Okay. Whereas further down, you can see our formula. If they are not mutually exclusive, we have this extra bit. So I'll explain what that is. Okay. So you randomly select one card. In this section, we're only doing one thing at a time. From a standard deck of 52, find the probability of selecting a 10 or a 3. So the number of things in our sample space is still 52. We want to find the probability of selecting a 10 or a 3. Okay. First thing you have to ask when you have the probability of this or that is, are these events mutually exclusive or not mutually exclusive? Can they occur at the same time? In other words, can they occur at the same time? So, I don't know, can a card be both a 10 and a 3 at the same time? Well, here's a 3, here's a 10, all right. Another 3. So it cannot be, one card cannot be both a 10 and a 3. So this cannot happen. If it cannot happen at the same time, they are mutually exclusive. Which means my formula is this one right here. Probability of a 10 plus the probability of a 3. So we know that there are 4 10s in a deck. You can look at that again if you want. I'm also holding on to my 3s. So like I've said before, if you want to buy a deck of cards, you can. You're not required to. There are resources online. If you just Google deck of cards, you can find an entire deck in a JPEG picture. All right, so we have 4 10s. We also have 4 3s. I pulled those at the same time. So 8 over 52. Let's reduce that. 8 divided by 52. Second PRB, if it reduces, it is 213. Most of these ask you for the reduced fraction. If the fraction is weird and ugly, it'll say, you know what, give us a decimal. But I'm going to usually be doing these with fractions. So, our other situation is if they are not mutually exclusive. That means that there is some overlap. So as I drew in my Venn diagram here, this little overlap is called the intersection. I'll usually refer to it as overlap, so not to get too mathy and confusing. But the formula says probability of A plus probability of B minus their overlap. So this is the overlap. So in this one, you're dealt a deck of one card from a deck of 52. Our number in our sample space is still 52. Find the probability that you are dealt a 7 or a black card. So we're looking for the probability of a 7 or a black card. Okay. In order to figure out what equation we're using, what formula we're using, we need to ask ourselves, are these events mutually exclusive or not mutually exclusive? In other words, is there overlap? Is there overlap, or can they happen at the same time? In this case, yes. If they can happen at the same time, they are not mutually exclusive. It's a little confusing. I think the language is slightly confusing, but it is what it is. Since it's not mutually exclusive, our formula will be probability of 7 plus the probability of black minus the probability of a card being 7 and black. Okay. So, again, I can go into my deck of cards because it's right here. You should know that there are 4 7s. You can go find them if you'd like. 1, 2, and there's those 2 7s. So there's 4 7s. I'm going to put them back in my deck. I'm going to find all the black cards. Well, I don't have to go through all of these. You probably can guess that if half the card deck is black and half the deck is red, then that means that 26 of these have to be black. Alright, so 26 over 52. And now we have to find the intersection. So we put everything back in the deck. I need to go and find all the cards that are both black and 7. Okay, there's some black cards. Alright, I'm looking for cards that are both black and 7 at the same time. There's probably some in here. We said there would be. Oh, there's a joker. That doesn't count. Alright. Oh, there's my 2 black 7s. So it has to be black and 7. There are 2 of them. So that is 2 over 52. Now, what I would recommend, rather than typing this in the calculator right away, is to do the following. 4 plus 26 minus 2. Let's clean up the top first. That's 30 minus 2 is 28. And now let's type that in the calculator. If you needed to do 4 plus 26 minus 2 to get 28, you could do that. But I would try to avoid complicated fractions and too many operations with my fractions. 28 divided by 52, ugly decimal, second PRV, 713. All right. All right, so there we go. That covers this section.